Hi, I'm from Papapodcasts, and today we'll be learning about potential differences. So first off, we'll talk about potential energy. Potential energy is energy which is stored into an object. An object can be anything like a ball. So this ball here right now, it has potential energy. Potential energy stays potential until the object moves, because that energy is now turned into motion, stating the law that energy is never lost or gained, it's only converted. So that potential energy would be converted into motion. So if I was to push this ball down like a hill, the motion, the potential energy from the ball would be transferred into the motion. So this causes the difference between charges in the two different terminals. Each electron has an electric potential energy. So the negative charges, which are electrons, would accumulate in one terminal, while leaving the other terminal filled with positive charges. If I was to connect a conducting wire between these two terminals, the flow would be from the negative to the positive, not positive to negative. And the difference between the electric potential energy of 2 points in any circuit is called potential energy, or it's measured in voltage. So now we'll be talking about how to measure potential differences in a circuit. So here, I'll draw the simple circuit. This being the symbol for battery. And this being a light bulb. So if I wanted to find the voltage, which is potential difference within the circuit, I would connect a voltmeter, which is explained more in the other chapters. So I would use the voltmeter. And I would have it connected between these circuits, or any two parts of the circuit, tell me the voltage. So now we'll be talking about currents and how to find a mathematical equation for them. The cell or the battery provides energy which pushes the negative charges through the conductor wire in the circuit, just as explained before in the experiment. When describing current, it's kind of like describing the flow of water. It's measured in how much liters pass a certain point in the pipe per minute. Except measuring current, electrical current, is pretty similar to it because you measure the amount of charge which passes through a certain point in the conducting wire per second. So the symbols for these are both charge, current, and time. I'll show you it in a chart. So, charge, which is the electrons which come from the battery. Charge is measured in Q. So, the symbol for charge is Q. And the unit, which is measured in, is measured in Coulomb, which you could represent as T, but it's spelled out as and the current, which is the charge over the time, the symbol for current is I, and its unit is A, which stands for ampere. Ampere. And time is the symbol T, and it's measured in seconds. S. Now we'll talk about the mathematical equation. The mathematical equation is current equals charge over time. Because the current, as I said, equals the electrons passing a certain point within a certain amount of time, which is seconds. So I'll show it here. So I equals Q divided by T. A simpler way to show this is using this pyramid with I being here, Q, and T. I'll explain how to use this pyramid in a bit when finding out the equation. So this basically is I equals current. So current equals the charge divided by time. As I said, time is measured in seconds. The charge is measured in Coulomb, and current is measured in ampere. There's also an instrument like the voltmeter, except this measures the electric current, and it's called a meter, but we don't really need to explain that. The circuit symbol for an ammeter would be an A, so like this was a battery, and it was connected in a circuit. The ammeter would be shown as A in a circuit. So now we'll be learning about calculating voltage. To start off with, all forms of energy are measured in joules. When describing energy in an electrical circuit, we don't measure all the charges in the circuit, we measure it per each charge. We compare one point in the circuit to another. Potential difference is the difference between the potential energy per charge in one point in the circuit and potential energy in another point in the circuit. The units for potential difference is voltage, and voltage is joules over Coulomb, which is energy over charge. I'll show it to you in the chart, like I showed potential difference earlier. This being the symbol, this being the unit. So as I said, energy, which is it's the symbol for energy is E, but its unit is J for joules. And charge which is measured in Q, but again, its unit is C for Coulomb. And there is potential energy, potential difference. And potential difference is, its symbol is V, which stands for volt. So the mathematical equation for potential difference is V equals E divided by Q, which is potential difference equals energy divided by charge. So here, V equals E divided by Q. We could also show this in a pyramid, just like I showed the calculation for the other one, which is V over E Q. So now we'll be talking about energized and de-energized charges and how they flow in a current. So right now in this diagram, the electrons are accumulating in the battery. This is the battery or the cell, whatever you call it. So they're energized through the chemical reactions in a battery, and they have the potential to do work. But since the circuit is closed, so the switch is not closed, they can't travel to the light bulb, which the light bulb is a load. And a load is anything in a circuit which converts electricity into another form of energy, proving that energy isn't lost or gained, it's only converted. So it could be anything like a motor, which transfers the electricity into heat, light, anything like that. So if I was to close the switch, the electrons from the circuit would move from the negative terminal all the way to the light bulb through the conducting wire. And once it gets to the light bulb would then turn on, but it turns on right away because even before the switch is on, there's still electrons within the conducting wire, as I showed in the experiment. So once this light bulb is turned on, those electrons have used their energy and they have then become de-energized. So these here are energized these are energized electrons, but once they have passed the light bulb, they already use up their energy and they've converted it into light, and then they become de-energized and they travel back to the battery to get re-energized. So these are de-energized. So once they come back to the battery has the chemical reaction and it re-energizes the cells so it can continue with the light bulb.
Hi, so now I'll be showing you how to use the following formulas to find the current and voltage, or in other words, potential difference. So I'll first show you the formula for current. This pyramid is an easy way to use and remember both formulas. In the current formula, it is I equals Q over T, which is current, I equals current, Q equals charge, and T over time. So current equals the charge which passes a certain area in a certain amount of time. So if I wanted to find out a variable here and I only knew two sets of information, I could using this formula. So let's say I didn't have Q, but I had I and T. So you just erase Q or cross it out, and then all you need to do is, since this line here means you multiply, like if they're right next to each other. So what I would do is I times T equals Q. You could also do that with the other possibilities too. So this time, let's say I had Q and T, but I wanted to find out I. I'd cross out I, or erase it. But this time, I would divide, because this top line here means I divide. So what I would do is Q divided by T equals I. Same thing for finding T. So at a raise to T, so I have I here. So since we're using this line again, we're dividing. So so it's Q. Since Q is at the top, Q over I, which is the same as dividing, equals T. So that's how you find out the different variables with only having two sets of information for the current formula. Okay, so now I'll show you the formula for calculating voltage, which is V equals E divided by Q. This pyramid works the same exact way as it does for the current chart. So V equaling voltage, E which equals energy, and Q which equals charge. So now that you know how to use the proper formulas for the proper equations, we'll be doing a few sample questions. So in a battery with 45 joules of chemical energy, which is then converted into electrical energy, this energy places 15 coulomb of negative charge at the negative terminal, leaving a deficit at the positive terminal. What is the potential difference between the two terminals? So we know that potential difference is the same as voltage. So potential difference. So we know we're dealing with the voltage triangle. So we'll use my triangle. So I have the formula for voltage is V equals E over Q. So a few key terms in this equation are 45 joules. Joules is the unit for energy. So we have the given. This is what we're given in the equation. So 45 joules. E, because joule is energy, so E equals 45 joules, which is the unit. We have the energy, the charge, which is 15 coulomb. Coulomb is the unit for charge, and Q is the symbol. So Q equals 15 C. And we need to find out the voltage. So what's missing is V. So using the triangle, we can cross out V. Now that we see is E divided by Q, we just need to put them in our calculator and we'll get V. So E divided by Q will equal V, and that's what we need to find out, because V equals voltage, which is also potential difference. So we'll input our data. So E is 45, Q is 15. So 45 divided by 15 equals 3. So our voltage between these two terminals is 3. So now that we have our answer, we need to finalize it with a therefore sentence or a statement including the question. So our therefore statement would be something like, therefore the voltage, which is the potential difference, you can say potential difference, the voltage between both terminals is equal to 3, and put volts, because that's the unit for voltage. Okay, so now that you solved a simple problem for voltage, you can use the same strategy to solve a problem on current using the current formula. But what if you had a problem involving both formulas? So let's try this one. In a circuit having a battery with an energy of 50 joules and a current of 200 ampere traveling at 10 seconds, what is the potential difference between the battery and the load? So the load being anything like a light bulb, for example, we need to find out the voltage or potential energy. So we need to find out the potential energy, which is also voltage, between these 2 points. So first, let's find out what we're given. So let's read over the question. In a circuit having a battery with the energy of 50 joules. So we know J is the unit for energy. So energy equals 50 joules. And the current is 200 ampere traveling at 10 seconds. So we know the current is 200 ampere. So the symbol for current is I. I equals 200 A for ampere. And it's traveling at 10 seconds. The symbol for time is T, lowercase t, equals 10 seconds. So what we need to find out is voltage. How do we do this? Let's try using our triangle. So we know voltage is in the voltage formula. So let's try that. V equals E over Q. So we don't have Q or V. We need to at least have two different sets of information to get another. But in the other pyramid, we have, for current, we have I equals Q over time, T. So we have the current and we have the time, but we don't have the charge. But we can find out the charge by multiplying I by T. So I times T equals Q, which is the charge. So we'll plug in our information. 200 times 10 seconds equals 2000 charge. So now we know that Q equals 2000 So we can plug that in to over here into this formula, and now we have Q and E, but we need to find out V. So we're using the top line, so it's E over Q equals V. So we can plug our information in now. E equaling 50 joules. The current, the charge equals 2000 equals 440. So now we know V equals 40. So we have 40V, and we paraphrase that in a therefore sentence. So we would say, therefore, the voltage between the battery and the load equals 40V.